So, so we, once. So I explained to you that what we're going to do is you would have to recap a bit of AS TK every time we start a topic. TK, so then we can build on top of that. So we started off with energetics, the first one. Hold on a second. So we started off with energetics. That's the first one, small topic, and we did some basic revision. And the revision included that we learned about bond energies. We learned about the formula of bond energies, which is bonds broken minus bonds formed. And we learned a little bit about the Hess law, which you already know. If you've done AS, you know what the Hess law is, that the enthalpy change of a reaction is the same no matter what path is taken. So if you have a reaction, the reaction could follow multiple paths. So carbon and oxygen can react to form carbon dioxide. And similarly, carbon and oxygen can react to form carbon monoxide first, and then they can form carbon dioxide. So the enthalpy change 1 is basically equivalent to path number 2, which is enthalpy change 2 and enthalpy change 3. So you have this relationship. Hess law helps create this relationships between enthalpy changes, and if you don't know one of them, you can figure that out by using the other two. So just this part. So let's try and do a quick recap first for about questions related to bond energy and questions related to Hess law. I'm more interested in Hess law, so let's start with some practice, because A2 energetics is something that's similar to Hess law. I mean, it's basically Hess law. So we will probably focus more on this. So let's do some practice of this. So एक second, कहाँ पे worksheet? Not. I mean, let's do the AS revision first. So drawing Hess cycle. Where's drawing Hess cycle? This one, the first one. Okay, so the idea is one path is basically equal to the other path in a chemical reaction, as long as you are making the same stuff, as long as your reactants and products are exactly the same. So for example, the first question, just very quickly, there's a Hess cycle that's drawn. You don't know what R, S, T, and U are. So which of the following statements are correct? The first one states that the enthalpy change for the transformation U to R is plus 42. So from U all the way, you have to go to R. So U to R is plus 42. So what is the Hess law that, what's the enthalpy change you're going from U to R? Now, one thing about Hess law is that if you go in the opposite direction of the arrow, the enthalpy change sign reverses. So if you want to go from U to R, you have to first reach S, and from S, you need to go to R. So U to S is minus 92, because you're going in the opposite direction, and from S to R, you're again going in the opposite direction, so that's plus 134. Is it minus 33? I think it is plus 42. Lamia, is this clear?
Yes.
Yes.
Yes, sir.
So then the second one is, he states that T2S is endothermic. So T2S is what? T2S is, you start off at T, you're going to S, so I'm going to take this path. So is it endothermic? This is minus 75, you're going in the direction of the arrow, so that's minus 75. And from U, you have to go to S, which is the opposite direction, so that's minus 92. So that is definitely coming out to be exothermic. It's going to have a negative sign, so it's not endothermic, it's actually exothermic. Okay, last one is R to T is minus 33. So let me rub off the other things. So R to T में क्या करना है? R to T में you can't go directly because you don't know what this is. So you're going to go indirectly. That's this path. So R to T is going to be minus 134. then it's going to be plus 92. And then this arrow has to go in the opposite direction, so that's going to be plus 75. So is it coming out to be minus 33? It's coming out to be plus 33,
Yes.
not minus 33. Okay, is this part clear?
Yes, sir.
So that's a very basic version of the Hess law. Okay, just slightly doing. Remember, A2 energetics has a lot to do with Hess law. When so, just practicing a few more questions. Now, here's a question which states. Now, this is a difficult Hess law question. ये वाला तो clear है ना सारों को? Is this clear? सारा clear है? बाकियों को clear है?
Yes.
Yes,
Yes.
sir.
So this one slightly more difficult. You already know what skeletal formulas are. This is cyclopropane. He says that the enthalpy change of formation of cyclopropane is 53.3. That's the first thing. Enthalpy change of formation. So that is 53.3. Well, what is cyclopropane? It's C3H6. I mean, this carbon will have two hydrogens bonded to it. This carbon will also have two hydrogens bonded to it. This carbon is also going to have two hydrogens bonded to it. So enthalpy of formation is when you form 1 mole of something from its elements. The elements are carbon, solid, hydrogen, which is gas, and it's forming C3H6, which is a gas as well. ये cyclopropane है, ठीक है? So enthalpy of formation is 53.3. Then he says the enthalpy change of atomization of graphite is 717. So I'm trying to construct a Hess cycle. What is enthalpy change of atomization of graphite? Graphite is carbon. Carbon होता है. Carbon को basically atomize करना है, ठीक है? You have to form atoms out of carbon. So I see carbon over here. So I take this entire thing and I atomize carbon. Carbon atomization is you turn it into gas. You turn it into gaseous atoms, ठीक है? I did not do anything to H2, so H2 is as it is. Nothing has happened to it. So how much energy is required for atomization of so how much energy is required for atomization of graphite? That's 717, but it's going to be times 3. I'm doing it for 3 carbons. ठीक है, atomization. ठीक है, अभी we haven't gone through definitions, but atomization is when you form 1 mole of gaseous atoms from its elements. So we're forming 3 moles. So that's 17 times 3. So फिर इससे आगे कि the bond enthalpy of HH is given. So I've got an H2 molecule over here. What I'm going to do is I'm going to break the bonds of this hydrogen molecule. So I'm not doing anything to carbon. Carbon remains gaseous. Nothing happens to it. But the hydrogen molecules, I'm breaking the bonds of these hydrogen molecules. So I'm going to get 6 hydrogen gaseous atoms. So if I have 3 H2 molecules, to break the bond of one H2 molecule, that's 436. So this one is going to be 436 times 3. So they gave me enthalpy of formation, which is 53.3. I wrote that down. Then I started constructing the Hess cycle. They gave me the atomization of carbon, which is forming atoms. So 717, that was given, times 3. They gave me the bond enthalpy for H2. I broke the H bond. I got 6 H atoms. That was 436 times 3. अच्छा, finally वो क्या रहा है? वो मांग रहा है कि he's asking for the value for the average bond energy of the CC bond. So there's a path that's still missing. The Hess cycle is not complete. So if I create this path, what does this path represent? What it represents is that I've got these gaseous atoms, and these gaseous atoms are combining to form C3H6, which is over here. So how many bonds do I need to form? I would have to form This is carbon, carbon, and carbon. So I would have to form three carbon-carbon bonds. And bond formation is exothermic, so I'm putting a minus sign next to it. So I need to form gaseous atoms turning into this. So I'm forming three carbon-carbon bonds. And I would have to form CH bonds, one CH bond over here, one CH, one CH. So these are all H atoms. I haven't drawn it completely, but these are all on the outside. These are H atoms connected to the carbon over here. So कितने CH bonds है? That's कितने हो गए? That's six, right? So I'm forming six CH bonds. And bond formation is exothermic. So that's my Hess cycle. That's complete. Okay, that's a difficult question. In A2, when we move to A2, you're going to get something similar to questions like these. Uh, so I've a complete Hess cycle. They gave me the CH bond energy as well. That was 410. So instead of writing CH over here, I'm going to write 410 over here. Yeah, that is also given. So the entire Hess cycle, which I've drawn, there's only one thing missing, and that's the C bond. That is missing. ठीक है? और ये याद रखना ये AS है, ठीक है? I haven't moved to A2 yet. So that's the only thing that's left. So and they're asking for that. Okay, find the CC bond energy. That's it. So the same thing. I'm going to apply the Hess law, which is what that one path is equal to the other path. So this is my one path, and that's my other path. They both should be equal. So that means 53.3 should be equal to the entire cycle. So 53.3 is one path, the direct path. It should be equal to what? 717 times 3. What do I have over 436 times 3? 436 times 3 है ये ना हाँ और क्या है 6 times 410 minus 6 times 410 or finally end with is minus 3 times cc, which is unknown. So I just have to make this the subject of the equation and I'll be able to figure out what the answer is. So ये जरा कैलकुलेटर पे निकालो क्या आ रहा है.
I'm getting 315.
ठीक है, so the answer ठीक है B. So the answer is 350. So that's the answer. So I'll just do a couple of more. ठीक है, I'll move on because A2 के अंदर we'll just practice more of it. ठीक है. Yes, I'm just trying to sort of just do a quick revision. So let's try and do this question as well. They've given us three enthalpy changes of different three reactions, and they're asking us to figure out the enthalpy change of this reaction over here. So how do we do this? So the only way this is possible is that I create an alternate path. Yeah, so I create an alternate path using the enthalpy changes that are given already. So what's given? That carbon monoxide can be turned into carbon dioxide. So carbon monoxide can be turned into carbon dioxide. So that's what I'm going to do. I see carbon monoxide over here. So what I can do is I can turn it into carbon dioxide, gas. Water remains as it is. I did not do anything to water. In this arrow over here, I did not do anything to water. So that's minus 283. Okay, pehla part ho gaya. The first equation, I've connected it. Second one, H2 can be turned into H2O liquid. So let's do that. I see H2 over here. So I'm just going to do exactly that. Carbon dioxide, I'm not going to touch. H2, I'm going to turn it into H2O liquid. So that's minus 286. Or फिर ये कि the other part is that the final step, there's a final step missing, which is this arrow. So what is this arrow? What happened in this arrow? Nothing happened to carbon dioxide. वो वैसे का वैसे ही है. It was carbon dioxide gas over here. It's still carbon dioxide gas over there. The only thing that changed was H2O liquid turning into H2O gas. So H2O liquid turning into H2O. So I have to go in the backward direction. So that's going to be plus 44, and that's my Hess cycle being complete, right? You very clear? Is this clear? This one.
Yes.
Yes, sir.
अच्छा अब ये कि चलो ये तो कंप्लीट हो गया ठीक है सो क्वेश्चन क्या था क्वेश्चन वाज कि you had to figure out the enthalpy change of this reaction so again one path is equal to the other path so that's my path number 1 that's my path number so they both should be equal so that's going to be minus so it's going to be minus 286 plus 44 this minus 283 over here has to go in the opposite direction so I'm going from this direction to this direction so minus 283 must reverse. तो ये क्या बनेगा? This will be what? 41
C.
CA. ठीक है? So that's your Hess cycle. Or so one path being equal to the other path, that's your Hess cycle. ठीक है? Don't worry अभी हम A2 के अंदर ना इसको थोड़ा डिटेल में when we do A2 questions we'll do a lot more practice. ठीक है? So let's keep the revision for Hess cycle to this point. ठीक है? Once we start A2 we'll cover more of it. So that's a Hess law. ठीक है? Now moving on. ठीक है? That's again AS. Now there was a shorter version of the Hess law which was Hess law formulas which were based on the same cycle. The Hess law formulas were अच्छा फॉर्मूला में ये होता था कि उसका फॉर्मूला सॉरी you drawing the cycle is like kind of difficult. तो फायदा ये होता था फॉर्मूला के अंदर कि you didn't have to draw the entire cycle and by just applying a formula you could actually figure out what the answer is. Now the Hess law formula was the formula was kind of conditional. I mean there's a condition required for the formula to apply. So the condition was that let's say you've got a reaction and you've got reactants and those reactants are turning into they're turning into products. So if you know the enthalpy change of formation of the reactants and you know the enthalpy change of formation of the like if you know this information it doesn't matter what the reactants are what the products are it doesn't matter what the reaction itself is as long as you have the data of the reactants the enthalpy of formation and you have the data about the products the enthalpy of formation the formula was simply that the enthalpy of this particular reaction was basically equal to the enthalpy of formation of the products minus the enthalpy of formation of your reactants. So a simple formula would be sufficient without going into details about drawing the entire Hess cycle. And that was it. And there was a second version of the same formula, which was, let's say you know the enthalpy of combustion of the reactants and you know the enthalpy of combustion of the products. In that case, the enthalpy change of your reaction was basically equal to the enthalpy of combustion of your reactants minus your enthalpy of combustion of your products. And these were your two formulas. So, but the formulas are conditional. You need to know either the enthalpy of formation या फिर ये enthalpy of combustion. ठीक है? So I'll just do a couple of questions. Again, this is Hess cycle. You can draw the entire Hess cycle, but it's going to take a very long time. Or you can just skip the Hess cycle drawing part and just use the formula. So I'll just do a couple of questions related to the formula. Okay, so let's do the first question. Okay, now you can do this by drawing the Hess cycle, or you can actually do this directly too. So let's try and do this directly. Enthalpy change of combustion of ethanol, that's what he's asking for. So what is enthalpy of combustion of ethanol? 1 mole of ethanol burns in excess oxygen. And what do you get? You get carbon dioxide and you get water. Okay, this is liquid, this is gas, this is gas, and this is a liquid. So he's asking us for this. What is the data that's given? The data that's given is enthalpy of formation of carbon dioxide. So we know we have the enthalpy of formation. This is minus 393. What else is given? Enthalpy change of formation of water that's given. That's minus 286. The आखिरी enthalpy change of formation of ethanol that's given. That's minus 277. अच्छा elements की जो formation होती है that's zero because you don't have to actually form them. अच्छा formula क्या था कि अगर सारों का enthalpy of formation is known, you know the enthalpy of formation, you know the enthalpy of formation, इसका भी पता है, इसका भी पता है, ठीक है, सारों का पता है. So the formula was that you just do product minus reactants. One thing I missed out is I need to balance this equation. So कितने कितने ऑप्शंस होंगे? That's four, four three कितना seven three I guess. तो इसको multiply by 2 करना पड़ेगा. This one has to be multiplied by 3. हाँ बस ये. So my formula is that if enthalpy of formations are given, it's going to be product minus reactant. So the products are these. So the product is minus 393 times 2 and minus 286 times 3 minus my reactant, which is what? Minus 277. तो बताओ क्या आंसर है इसका?
B.
B. So I guess it's going to be. किसी ने confirm किया? Anyone else?
B sir. Yes, it's B.
Okay. Okay, so the formulas are simple. It's just
Sir,
हाँ जी.
aren't we supposed to find enthalpy change of combustion?
हाँ. वो ये है ना. This is enthalpy change of combustion of ethanol.
Okay.
वो मैं फिर से क्लियर करूँ. Reaction जो है ना, जिस जो आप ढूंढ रहे हो, that is kind of, I mean, this was enthalpy change of combustion of ethanol, right? One second. Just 1 second. My board up, hung up. So मैंने पहले explain किया था कि reaction जो मर्जी है ना, reaction is not important. The reaction could be anything. What is important is what is the data that's given to you. So that's उसके ऊपर formula decide होगा. So this equation is enthalpy of combustion of ethanol, but the data that's given is the enthalpy of formation of the reactants and enthalpy of formation of the products. So you're going to go with product minus reactants, ठीक है? तो अगला बस वो मेंटली कर लेते हैं कि बल्कि जल्दी से बता दो इसका क्या होगा. It's enthalpy of formation of H2S that's given minus 21. Enthalpy of formation of O2 that's 0. You don't need to form O2, right? It's already in its elemental state. As enthalpy of formation of water liquid, that's minus 286. Enthalpy of formation of S2, that's minus 297. So you're going to go with product minus reactants, which is going to be what product here. Product is 2 waters, so that's 2 times minus 286 and 2 SO2, so that's 2 times
D.
minus 297, that's product minus reactants. Okay, so the reactant is just H2S, so that's 2 times minus 21. So क्या है D? ये clear है?
B.
अच्छा B, sorry. और एक combustion का कर लेते हैं. One, let's find out combustion. This one is combustion that's given. So with combustion, if the data given is for combustion, then it's reactant minus product. So carbon, that's minus 390 what 4 times 4. H2 is minus 2. Get that minus 286. times 5, and this is minus 2877. So you know the combustions of the reactants and the products. So with combustion, it's going to be reactant minus product. So it's going to be minus 394 times 4 and minus 286 times 5. So that's my reactant minus my product, which is minus 2877. So क्या है इसका?
B again, sir.
B?
Negative 129.
Yeah, that's negative 129. So going back, I'll send you the worksheet and the solution as well. Okay, that's a yes. So just remember that there are going to be two formulas related to Hess law. One is the difficult part where you have to actually draw the cycle. ठीक है, ये वाला पार्ट ना हम थोड़ा A2 में भी slowly करेंगे scratch से, ठीक है, फिर से, लेकिन with specifically applied to A2. This is the simple formula. अभी तो कोई confusion नहीं है, दोनों clear है ना? Arun, Lamia, Naseem, is this clear?
Yes, sir.
ठीक है.
Yes.
अच्छा, अब ये कि we've got Q is equal to MC delta T. I'm going to do that at the end. So I'm going to start to briefly move into A2 now. पहले तो थोड़ा definitions. So we're going to start with AS definitions. Okay, then we'll move to. I said remember concept E here. A2 is the same thing. Okay, just a different application. And a couple of more definitions. That's it. So starting with definitions, and again, so starting with AS definitions, they were kind of like kitni thi? Four, I guess. There was delta HR. There was bari likh lete hain. What is delta HR? Delta HR is when somebody tells you delta HR or standard enthalpy change of a reaction. So this was standard enthalpy change of reaction. So it could be exothermic or endothermic. This is the most generic definition. When they say R, that means it's the enthalpy change of a reaction or energy released or absorbed when basically any reaction happens. So this is the most generic form of definition. So enthalpy change of a reaction, but with one condition. Okay, जो moles that are given in the equation, the enthalpy change should be calculated for those exact moles. So if an equation has 2 moles of carbon dioxide, so the enthalpy change should be calculated for those 2 moles of carbon dioxide. So it's the enthalpy change of a reaction when stoichiometric moles of reactants and products are stoichio. क्या spelling होता है? Stoichio. I guess that's it. Stoichiometric moles. Stoichiometric moles is the moles that are written in the equation. So when stoichiometric moles of reactants are used and products are made. If I say that N2 and H2 they react and they form, let's say, 2NH3, ignore the reversible sign. And the enthalpy change of reaction given, or the standard enthalpy change, is kind of measured under standard conditions. So measured under standard conditions. So if N2 and H2 react, the delta HR is given as minus 88 kilojoules per mole. ये जो पहला वाला delta HR है ना, that means this enthalpy change is exactly if 1 mole of N2 is used and 3 moles of H2 are used and 2 moles of NH3 are produced as a result. So this enthalpy change is specific to these stoichiometric moles. असल में जब आप reaction करते हो, you don't use 1 mole of N2. You use if there's an industry, they would be using a lot of N2. They might be using 3,000 moles of N2. So this enthalpy change is not for that particular reaction. It's specifically for the moles that are given in the question. Yeah, that's the first one. और फिर जल्दी से वो कर लेते हैं कि अच्छा, तो ये clear है कि अच्छा, and this one is important because remember this, when they use delta HR, तो अक्सर question में ना, what you have to do is you would have to use ratios at the end के maybe they're calculating it for like 0.1 moles, so you extrapolate it, you use ratios and you find out okay, what is the energy change for 1 mole of N2. So you have to be careful. If they're looking for delta HR, then you have to exactly give them the value of delta HR. Delta HR clear है? ये पहले भी किया हुआ है, ठीक है? Is this clear?
Yes.
अच्छा, delta HF, delta HC, I think familiar ही होगा कि उसकी definition नहीं लिखते हैं, just they're never really going to ask you. I've never seen an A2 paper where they're going to ask you for the definition of delta HF, but you should know what it stands for. Okay, it's going to be appearing a lot of times. So delta HF क्या होता था? Delta HF होता था standard enthalpy change of formation, right? So what would happen in delta HF is that you had elements, and the elements, they were supposed to be in their standard states. And what would those elements do? Those elements would form 1 mole of a compound. So if you're doing this under standard condition, then that's it. Okay, that's your enthalpy of formation. So I'll just give you some examples. Like if they tell you enthalpy of formation of ethanol, so 1 mole of ethanol, C2H5OH, liquid. It should be formed from its elements. The elements are what are the elements? Carbon. That's a solid. And I've got CH2 gas molecules. And I've got half O2 gas molecule. So that's so the enthalpy change of this reaction is enthalpy of formation. And remember, enthalpy of formation could be endo, it could be exo, because in delta HF, both reactants, both bond breaking and bond formation is happening. So it could be exo or endo depending on what the reaction is. You would have to break bonds and then you would have to form new bonds. So it depends. If more energy is needed to form break bonds, then that's it's going to make it endothermic. Okay. So enthalpy of formation, enthalpy of combustion भी जल्दी से, ठीक है, notes जो है ना वो काम आ जाएंगे, इसलिए वो लिख ही लो. enthalpy of combustion के बाद जो है ना वो एक रह जाएगा, neutralization. ठीक है, you did 4 enthalpy changes. So what happened in combustion? Combustion, you just burnt something. So you had a 1 mole of substance, anything, and it would just spontaneously burn in excess oxygen. So you're going to get so burns in excess oxygen, so it will produce, so it's going to be complete combustion, not incomplete combustion. So whatever the enthalpy change for this is always going to be exothermic. And so 1 mole of substance burns. And then you have, so I'll just give you some examples. Ethanol है, तो ethanol का क्या होगा? 1 mole of ethanol, that's C2H5OH. You have to keep this 1 mole. It burns in excess oxygen, so when it burns complete combustion, it's going to form carbon dioxide and it's going to form water, which is a liquid. ठीक है, तो ये gas है, and this one is a liquid. और क्या रह गया? और you just have to balance it. So it's going to be 2 carbon dioxides, 3 H2Os, and I guess CO2. This has to be kept as 1 mole. ठीक है, तो ये enthalpy of combustion है. और इसके अंदर ये याद रखें कि formation of elements is always 0. So delta HF of elements and इसमें याद रखना है कि delta HC of let's say carbon dioxide is 0 because you can't burn it in oxygen, you'll still get carbon dioxide. और बस ये delta HC of कौन सा और water is 0. Your water burn करोगे oxygen में, so you're still going to get water. So basically nothing will happen. Delta HC of sulfur dioxide, so the combustion product, the enthalpy of combustion is always 0 because they're not going to burn in excess oxygen. You'll still get the same thing. चलो ठीक है, यहाँ पे खत्म करते हैं. ये क्लियर है? ये इधर से ना फिर कल A2 स्टार्ट कर देंगे. ठीक है, ब्रीफ हमने हेस साइकिल वगैरह किया. A2 फिर हम थोड़ा डिटेल में इन डेप्थ करेंगे. ठीक है,
ओके.
चलें कल फिर ना we'll continue with A2. We'll start with A2. ठीक है, okay then.
Okay, sir.
ओके, अल्लाह हाफिज़.
Hafiz.
Allah Hafiz.
Assalamu alaikum, sir.